Welcome. My name is Rob Miller. Today we're going to take a look at just how easy 3D laser scanning is. With millimeter accuracy and quick turnarounds, it's easy to understand why scanning has become one of the most talked about technologies with architects, engineers, and contractors throughout the industry. From scan to registration to analysis and modeling, Trimble's 3D laser scanning solutions are changing the way contractors work. From performing the scans in the field through preparing the data for handover back in the office. We'll cover each step of the process. Let's head out to the field and get started. As you can see behind me, we're here at a newly completed warehouse and manufacturing facility. This is a perfect scenario where the final structure is scanned and processed for delivery to the owner. Using these scans, the owner has an immensely powerful tool where they can easily plan renovations, remodels, or adaptive reuse. The first thing we should always do before performing any scans is to walk the project to have a clear understanding of the site. 3D laser scanning can be utilized for a variety of needs, including generating 2D drawings, capturing manufacturing level details, or confirming the accuracy of existing construction documents. Knowing exactly how the data will be used and by whom will have an effect on the amount of time you'll spend in the field performing the scans and processing the data back in the office. For this job, we plan to use the scan data to create 2D construction drawings for record, verify dimensions throughout the facility, and model the warehouse to LOD 200. To learn more about the LOD specification, simply check out the video linked below. When scanning a building or a structure, it is rare to be able to collect all the data that's needed from a single scanner setup. So we will need to move the scanner to multiple locations to collect all the data that we need. The number of setups, known as stations, is dependent on the capabilities of the scanner, the size of the project, and how much detail you need. Be sure to walk around the site and position yourself where you expect to set up the scanner. Keep in mind that the 3D laser scanner is line of sight measurement, so if you can't see it from where you're standing, neither can the scanner. For this warehouse, I'm going to use both checkered targets as well as spheres. I'll place the checkered targets on the walls throughout the facility. A benefit of these targets is that I can leave them up after I leave, just in case I need to come back and perform any additional scans. When planning your scanner setups, think about how the data will be used and the level of detail that you need to collect. It is possible for each setup to have different settings based on the objects being captured in that scan and the distance that they are from the scanner. The settings that you choose will affect the amount of time it takes to perform each scan, but don't be in too big of a hurry. Spending a little extra time on the site scanning could prevent a return trip to the field. Be sure to keep the area in front of the scanner clear from any people or objects that you aren't interested in. If you do have people walk in front of the scanner while it's going, you can remove those points pretty easily back in the office. Unless you have something stop in front of the scanner and block it, it's probably okay to just let the scanner keep going. Once the scanner has finished, move to the next station and perform the next scan. Don't move or tear down any targets until you're sure that you're done with them. With our scans complete, we're ready to head back to the office and process the data. Now that we're back in the office, we're ready to process our scan data. We're going to cover 3 topics: registering the scans, loading the points, and then cleaning up the data to prepare it for handover to the project team for analysis and modeling. Let's open Trimble RealWorks and get started. For this project, we're going to perform a plane-based registration, even though we place targets. Along with the registration, we're going to have the software generate preview scans for each station. These are low-density point clouds that will allow us to visually inspect the registration results before we load a high density of points. We have sped up the registration for this demonstration, but the time that it takes to complete the registration will depend on the number of scans and if you're doing plane-based or using targets. We can review the registration results to see how well the data statistically fits together and if there are any stations that fail registration. If we do have a problem, we can register those stations using the targets. We can see that the registration was successful and our stations line up well with each other. The result is a single point cloud of the warehouse and manufacturing facility, just as we want. With the registration successfully completed, we can now load a higher density of points. We have the flexibility to define the sampling rules for each station. This can be useful for managing the amount of data and detail we have in our project. With all of our points now loaded, it's time to do a bit of cleanup on our project. Let's take a look again at the software and see how this is done. Because we're concerned with the warehouse and manufacturing facility floor space only, we have a very clearly defined area that we're going to be working with. In order to do this cleanup, we're going to use the segmentation tool to start breaking up this data into parts. We can see that there are points that are outside our area of interest, so we're going to remove these first. We will draw a boundary around the area of interest and remove everything outside of it. Some of these points are of other rooms in the facility that we captured through the windows, while others are the result of reflection of the laser. We will do this process from different view perspectives to make sure we get rid of all unnecessary points. It is a good idea to view the data different ways to help identify these outliers. You will find that some things are more visible when rendering all points in white rather than grayscale. Some may even be more visible when colored by elevation. In addition to cleaning up the exterior, it's important to check the interior for unwanted points. It is likely that you will end up with people or objects in the data that you don't want included. As we inspect our data, we can see that we have some people in the scans that we want to remove. Similar to how we segmented the data outside our facility, we will segment these objects inside. Be sure to spend some time looking for other objects that need to be removed. In our project, there were some trash cans that were left out while we were scanning. We want to go ahead and remove these now so that they don't impact our analysis or modeling later on. Our data is now ready to hand over to the architect, engineers, construction project manager, and the design and detailing group. We were able to complete all of our field scans and office processing in just under a day. A very short time given the amount of information that we now have access to. Each of these project stakeholders will likely utilize the data differently. The project team will verify dimensions, generate 2D construction drawings for record, and create an LOD 200 model for the owner to coordinate operations along with future renovations and facility updates. Thank you for taking time to watch this video. And remember, you can follow us on LinkedIn, Twitter, YouTube, and Facebook. From all of us here at Building Point, have a great day.